Where's my screen? So this is a sample of a common error message in the past. As you can see, this is an FTP connection to an FTP server, and then the message says something like the server is busy, so please try again later. So what do you think why this happened? If you remember from the previous meeting, we have something called a backlog. So it's the length of the queue in which the server allows how many clients to wait before they are accepted by the server. So if you have a queue of length, let's say 6, then say the maximum number of clients connected to your applications, it's 6. And then if the 7th client coming in, and then when the 7th client is coming in, no other client in the queue have been accepted. So the queue is still full. And then what happened is you'll get something like this error message. Sorry, wrong screen. So you'll get something like this error message. So that says the server is busy because the queue is full. It cannot accept any more client at the moment. And then the other clients already in the queue have to wait. And any new client is rejected. So how do we can make the server, or how do we increase the server capacity of handling multiple clients? The answer is using a thread. So before we move on forward, I need to know what you have in mind when you heard the word or the term thread. So join the ClassPoint application and put down your answer. So what you think is a thread? You can use any language. It doesn't have to be in the network programming context. It can be anything that you know about a thread. Then we'll see the connection from there. Okay, I'll give you 3 minutes maybe. Okay, we have 24 participants here. on, join the class point. Okay, let's see the responses. Who's that? I can't see the name. Anyway, somebody says benang. Yeah, the literal translation of that to Indonesian is benang. Asynchronous program, and then somebody says benang yang bersimpulan. Fraction of process. Yes, that's correct. Sekumpulan perintah unit terkecil dari suatu proses dalam OS, ya juga bisa. And then process that running independently from its parent, program that creates new threads. So multiple process can be done at the same time. Okay, I think what Excel means is multiple activities or multiple programs can be done at the same time, because process is a running program. And then in the context of operating system, thread is just like benang basically. So, but imagine with benang, it's made of some, I don't know, something like it's made of some molecule atoms and so on. But thread in the operating system consists of codes. So each thread it has its own code to execute. We'll see the illustration later. We'll discuss this first. Part of process in computer, yes. So essentially, a thread is a part of a process in a computer, and then unit terkecil dalam suatu proses yang dapat dijadwalkan oleh sistem operasi. Yes, that's also correct. Sekumpulan perintah yang dijalankan sejajar oleh komputer bisa digambarkan sebagai sebuah benang. Yes, so essentially it's a collection of or a sequence of instructions. For parallel tasking, yes, obviously one of the usage of using thread is for doing parallel computations, and then thread is a path of execution within a process. Yes, this is also a correct term in terms of network programming and operating system. Okay, I think most of you already knows what a thread is. So let's revisit some basic concepts. So a thread is, again, essentially it's an independent path of execution in the virtual machines. Why it says the virtual machines? Because we're talking about Java specifically. If you don't know about this, in Java, when you run a program, Java will run a virtual machine called JVM. And then inside that virtual machine, it will run your applications. So it runs the application inside the Java virtual machine. So that's why here it's in the virtual machine, because we're talking about Java. But normally, if we're talking about the operating system in general, it's a thread is an independent path of execution in the operating system. So basically, a thread has its own code, but it can share some information or variables with the other threads in the same process. What else? The characteristic of a thread. So here the illustration. If we have a process running in our computer, and then if the process has multiple threads, then we kind of have lots of workers inside the process. So instead of having just one person doing multiple tasks, we have lots of person doing many tasks. And each person, they may share the same code or they may share the same task. So the thread, these are the threads. The threads may share the same code, or they can also run different code from the process or from the other threads. So you can write a specific code for a specific thread, or you can just use the code from the parent process for the thread to run. Both are possible. So what are the uses of a thread in socket programming? There are many things. I only mentioned 3 of those. I believe there are more of these. One of them being handling many clients at once. So if we use thread, we can handle multiple clients at a time, as long as we have multiple processor, and as long as we don't use Python. So that's one of the reasons why I hate Python, is because the multi-threading in Python is fake. So in Python, even though you can have lots of threads running virtually at the same time, but actually Python will only utilize one processor at a time. So even if you have many processor in your computer, let's say if you have 2 CPU or let's say 8 cores, Python will only use 1 core for the computations. So if you have many threads, it won't speed up the computation using Python. That's why I hate Python. But I also need it. And the second usage of a thread in socket programming is to enable the server applications to do other things while waiting for the data. Because we don't want the server application to stop waiting for the data while it can do anything else. Like, for example, maybe writing to a file or monitoring its own activity, or maybe monitoring its own resource usage, something like that. And then if you're talking about the client side, by using thread, it enables us to render the graphical interface while we also receiving the data. So without the multi-threading approach, you won't be able to move your mouse, or you won't be able to click any buttons on your applications while you're waiting for the data to arrive. Because when you're waiting for the data, or while you're receiving the data, the the thread or the program itself will block for a certain amount of time, and then you can't do anything else unless, again, you have multiple workers to do your stuff. So that's why we use thread heavily in socket programming. So let's go on to the implementing a thread in Java. Has any of you done this before in the object-oriented programming? No? Anyone at home?
Yes, maybe.
You did, Vishnu?
Yes.
Okay, so this is the step-by-step on how to implement a thread in Java. So we're not going to be talking about multi-threaded web server for now. We're just going to be talking about how to implement thread in general in Java. So the basic concept is pretty much similar in the other programming language. So you have the code to run, and then you have a way to create the thread. So first is how do we create a thread is by creating a new class. We need to create a new class that either extends the thread class or implements the runnable interface. So if you see the example here, I have a class called myThread, and then it extends thread, or I can implement runnable. What's the difference? So there are two ways of doing it. What's the difference between the first one, when we extend the thread class, and with the second one, when we implement the runnable interface? So what's the difference between extends and implement? I will question your object-oriented knowledge. What's the difference between extends and implements? Anyone still remember?
Maybe either.
Sorry.
Okay. Is my voice clear?
Hang on. Let me mute my microphone. Let me mute my microphone, and you can talk.
Okay. Okay, sir. Okay. In my opinion, if we were using extends, we could not extend any other class again when we need it anymore. But maybe for the implements, we could extend other other classes, and maybe some of the implementation of any other classes in the class. Maybe that's my opinion.
Okay, well, your opinion is actually a fact because when you in Java, you can only extend one class, so you can only derive one class from the other, but you can implement as many interfaces as you want. So in case you need your class to extend from some other classes, but not the thread class, maybe you will need to implement the runnable. But if you only use this class to extend from the thread class, so that means you can use the extends one. So both are valid ways of doing it. It depends on the situations. So I'm gonna talk how to do it in both cases. Then after we create a new class, there's one thing that we need to do. We need to override the run method. So in the thread class, there's an abstract method called run. And then in the runnable interface, there's also another method with the same name. So our job is to override this method. So we kind of fill in what we need to do when the thread runs. So we need to write the code somewhere over here. You'll probably need to add something at the top, but it's the job of IDE to do that. But let's focus on the run method. And then after we override the run method, so we wrote our code after we've written our code inside the run method, the next thing to do is we have prepared the template. So we have prepared the thread to run, but it's not running yet. So for making the thread start running, first we need to create a new thread object. So if you look at this, I put a quote here because it's not actually a thread object. So it depends on your first approach. So if you use the extend approach, so this is the way to create the new thread object. So basically you just instantiate a new object using the keyword new. So sorry, wrong screen again. So this is the way to do it if you're using the extend method. So you kind of just instantiate a new object of my thread like usual using the keyword new. Or if you're using the implement approach, you need to instantiate a thread object like this. So you instantiate a thread object with the object of the new class as the parameter. It's actually as. I have a typo. It should have been as. Okay, so this is the example. If you implement it from the runnable interface, you create a new thread object, and then you create a new thread object with the class that implements runnable interface inside the parameter, something like this. And then next, what do we have to do? We just need to call the start method. And it depends on the approach. If you use the extend approach, because I'm using my thread as the variable name, I use my thread.start. In here, I start using the object of thread, not this object, but this object. Okay, let's do some exercise with the NetBeans and see what happens. Okay, let me share the screen first. Okay, can you see the can you see my NetBeans? Anyone?
Yes, sir.
Okay. Okay, now let's try. So first, again, we need to create a new class. So I have a new project here. Then I'm gonna create a new class, new, and then Java class. Can you see the popped up windows at home?
Yeah.
Okay. Let's call this my thread. Okay. Again, what we need to do is extend or implement the interface. Let's use the extend. Okay, and then now we just need to create an empty constructor because we're not using it for now. And then we also have to override the run method. Okay, this is what I meant. It's just to show that we are overriding the method from the parent class. Okay, what we need, so what are we going to do? Let's just print some numbers, right? I'm gonna print some numbers here. 0 to 10. Okay, I'm gonna print number. Okay, so we overrode the run method. We created the new class. Now, what we're gonna do is we just need to create an object of this thread. So let's try to create a thread. Not thread, but my thread. Let's say my thread one, new, and then my thread. We have the second one. Okay, we instantiated the objects. Now, what we need to do last is to start. Let's do some printing to see what happened nicely. Starting thread one. Starting thread two. And then we just have to call the method. Okay, we have done this, I think. Now let's see what happens if we run the program. Okay, there's some compiling. Let's wait. Okay, it takes a while. Okay, maybe any questions while waiting for the downloading process?
Excuse me, sir. May I see?
Yeah, hang on. Let me mute my microphone first so we don't get feedback.
Okay. Can I see my thread class again? I mean the codes that available at that. Just
This one?
okay. So it is different from the download process that has happening before. Yes. Uh, actually,
Say that again.
Okay. Actually, I see in the terminal before there is some download process that has happened. It is just the NetBeans trying to download all the dependencies that needed to these Java programs, or maybe it is related to the thread, or maybe.
Oh, okay. Oh, it's not related to the thread at all. It's just part of NetBeans that downloading some, as you said, dependencies from the internet. But no, it's not part of our program. So the part of our program starts from here. So as you can see, we have starting thread 1 and we have starting thread 2, and then in the middle we should start the first thread, and then after this message we should start thread 2, and then as you can see we have number 1, number 1, number 2, number 2, number 3, 3, 3, 4, 4, 5, 6, 7, 8, 9, 10, and then 5, 6, 7, 8, 9, 10. So if you can see, the order of the execution is not exactly deterministic. So it means that if I run this code again, we are supposed to get a different result. Let's see. Yeah, see, now it's 1, 2, 3, 1, 2, 3, 4, 5, 6, and then back to 4, 5, 4, and then 8, 9, 5 again, 10, 6, 7, 8. So if I run this multiple times, the order of execution usually is different. But it's not our purpose here. It's just nice to know that we can't control the order of execution of a thread. So keep in mind, because this will be a problem later. But for now, it's pretty much safe. Okay, if you wanna see the code, this is the code for the thread one. Can I make this side by side? I don't think I can. Okay, now let's go back to the slide. So in the first case, the thread doesn't have any information from us. So it doesn't have any information from the main function or the main class. But if we want to give some information, or if we want to share some variables to the threads, we can do so by using the constructor parameters or using a setter methods. So let's go back to the NetBeans again. So let's say I want to give my thread a name. So I want to give my thread a name, and I want to print the name of the thread, so I know which thread's running first and which thread is not, which thread runs last. So what we have to do is basically we need to create an attribute here. Let's say this is the name of the thread, and then if I use the constructor method, I can do so by using something like this, put it in the parameter, and then I'm just gonna assign the variable to that parameter like this, and then I can write it down here, something like this. So I added the name of the thread just before the number, so we know which thread is running. Now let's execute it. I think we made a mistake, didn't we? What was it? Oh yeah, because we didn't change this. So let's say this is thread one, and then let's say this is thread two. Okay, now we can see which thread runs first. I can't see it from my side. It's a bit hard. So thread two run first, and we switch to thread one, and then we back to thread two, and so on. But this is how we pass a variable or pass some information to the thread, by using the constructor. But the problem with constructor is we can only set the variable during the instantiation process. So we cannot set the variable once we create it or once we instantiated the object. To be able to do so, let's say if I want to change the name after sometimes, maybe I can create a setter method. So how do I create a setter method? This is the lazy way of doing it. Refactor, and then I think which one is rename this variable This one, encapsulate fields. So you can create getter and setter methods. I think with VS Code you can do it easier as well. So what is a getter and a setter methods? So as the name implies, setter methods means a method we use to set the value of a class attribute, of a private class attribute, because normally the class attribute is private. So that means it can't be accessed from outside the class itself. So we need the getter and setter methods. Oh, but apparently we already have something called name. Let's replace this with a different name. Nama. Sorry. Rename. Okay, now let's encapsulate the field. Refactor. Okay, now we have the getter and the setter method. And then at some point in our code, let's say I want to change the name. I don't like the thread one. At some point, I want just to change the name. I can call this function or this method, like my thread one dot set nama. Let's change this thread one. And we're gonna run it, then see. Oh, it didn't change because, yeah, this one is get name. It's because in the thread class, we already have an attribute called name, and we also have the getter and setter method with the same name. So we have to use a different name for the name variable. Okay, as you can see here, the name of the first thread has changed. So it's not thread one, and then thread two, thread not thread one again, and so on. So that's how you pass some information to the thread using the getter method, using the setter methods or constructor parameters. Okay, now go back to the slide. So if we can set some variables and then we can put some initial input to the thread, but how we can get the written values from a thread? Because both run and start methods, they do not return a value. So both has the written value of void. So how do you return your computational stuff from the thread? What would you do? Or how to store information in a thread and then return it to the caller? Does anyone have any idea? Anyone? No, we actually already did it before. Maybe you didn't realize it. But because we have a setter method, we have the pair of the setter, which is the getter method. So we can store the result of our calculation in a class attributes or in a class variable. And we just need to create a getter variable for that method. So for example, if I want to, let's go back to NetBeans. Let's say instead of just calculating some numbers, I want to calculate the sum of the first n numbers. That's it, like that. Let's change this a bit. So I have n, sorry, in n. So that's the the number of numbers that I want to sum them up. And then let's say I have this private variable. Okay. Let's create the getter and setter. No, we don't need this actually. We don't need the getter setter method for n, and then for e from 1 to n. Let's say I have let's create a temporary variable called result. So results gonna store the sum of the numbers, and then I'm gonna initialize this variable to 0. And then I'm just gonna do this. Okay, so we're gonna sum them all up with a thread, with two threads actually. Okay, so our problem now is how do we pass this variable, or how do we return this variable, because this is the result. How do we return this to the main function or to the caller? So the way to do that is by introducing the getter method. So because this is a private variable and it's not supposed to be able to be modified by the other method outside the class. So we just have to refactor and then encapsulate field. So we're just gonna introduce the getter method for that variable. Okay, it's something like this. We did it, and then we started it, and then we expect to see some result here. So let's say after summing them all up, I'm gonna print the result. So I'm just gonna say result from my thread one dot get nama is get result. And then I'll do the same for the second thread. Just change this. Okay. Then let's say this one's 10, this one's 20. So it's gonna sum the first 10 numbers, and then this is gonna sum the first 20 numbers. Okay. Can you guess what the output of these two lines? What's the result of, or what is printed by these two lines? Anyone want to guess? Oh, I didn't see the chat. Okay, so Vishnu says 55 and 65. Anyone has any other guess? Not sure. Okay, let's run it. Oh, apparently the result from thread 1 is 0, but the result from thread 2 is 150 or 90? 90, I think. 190. Let's run it again. Maybe it's a glitch. Oh, it's still the same. Why? What happened? Now let's run it again. Run it again. Hopefully we get different result. Well, unfortunately not, but we're supposed to have a different result. Okay, anyway, that's a problem. Does anyone know what's this problem called?
I think because the printing result function is called before the thread is completely finished running.
Exactly.
So the result is like that.
Yep, that's correct. So it's caused by this line. This line is executed before the thread 1 finishes. So because this one is executed before thread 1 is finishes, we don't have any result yet, and thus we have 0. While the other thread, it may have finished running. That's why we get quite a big number. I don't really know the sum of 1 to 20. But anyway, this is all we get. So if you remember this, we have a problem called something similar. Let's go back to the slide first. Okay, now let's open your class point and see if you remember. What is a race condition? Hang on. There you go. Which one of these statements is the definition of race condition? Okay, let's see the result. Okay, some of you says A, some of you says B, most of you says B, and the rest is C and D. So the correct answer is B or 2. So a race condition is a condition in which two threads are competing for a resource, or sometimes it also happens when we don't know which threads runs first, and the result of our code is inconsistent because we cannot control the execution of the threads, which just happened which we just saw earlier with our example code. So the first one is actually not wrong if the context is obviously not network programming and operating system. And I intentionally didn't put the context here. And then the 3 and 4 is quite wrong. So it's not the definition of race conditions. So yeah, so the correct answer, the most correct answers given the context is the second one. So it's a condition where two threads are competing for a resource, just like we did the main thread. Oh yeah, I need to mention. Sorry, I need to ask you, how many threads we ran in the previous experiment?
I think it's about 3, sir.
Sorry, say that again, Axel.
3 thread.
3. Okay, 3. Axel says 3. Anyone has another opinion? Why not 2?
Because it is the 2 thread that we create and 1 for the main function.
Yep, that's correct. So we had 3 threads during our previous experiment, 1 for the main class or for the main thread itself, and then the main thread will spawn 2 other threads. So in total, we have 3 threads, and the competing threads are the main thread and the thread 1. So thread 1 is trying to increase the value of the result variable, while the main thread was trying to get the value of the result variable. So they're competing, and in the end, the main thread wins, and we got the wrong result. And it also happened with the public and private libraries, because with the private libraries at your home, you can basically use or read your books anytime, and you don't have any competing, usually you don't have any competing person to read the book. But with the public libraries, you have lots of books, and lots of people maybe trying to read the same books as you, so you have to compete to access the books, to read the books. And how do we prevent that? We have to synchronize. So we kind of make sure that we don't both get access to the same book or the same variable unless we are allowed to do so. So yes, so this is a way to prevent race condition. We using synchronizes. It's so hard to pronounce this. Synchronization. Okay, so how do we prevent a block of code from being interrupted? We can use in Java. There's a keyword called synchronize. In C, I think we can use mutex. I think you used it. Did you use it during your operating system module? No. Mutual exclusion, and then in Python you have the same concept because Python is built on top of C. What other language? Okay, essentially, there's always a way for us to prevent a block of code from being interrupted. So we can use the synchronize keyword, something like this. And the synchronize keyword can be used, or it can be applied on a block like this. So we have a block of code surrounded by the curly brackets. And then in the synchronize, we mention which variable or which resource we want to protect. So when a block of code reads this statement, it will execute all of these lines and it won't be interrupted. So as long as it's inside this line, it won't be interrupted. Or we can apply the synchronize keyword on a method, something like this. So public synchronize void write entry. So this means these functions, these write entry functions, will be executed and it won't be interrupted, or it at least it won't be stopped or paused by the other threads. Okay, before we go into the thread priority, let's try that approach on our previous code. Let's see if it works. So which part of the block you want to protect? Is it on this one or this one? Which part of the code that you need to run until it finishes before you can start doing something else? Okay, the hint is it's on this file. Which line of code do you need to protect from being interrupted? Anyone?
I think the entire four statements.
Can you mention the line numbers?
The 32 until 35.
Yes, 32 until 35. So let's try to put the protection here. Let's see if this works. And what I want to protect is the object of this class. That's why I call this. Okay, let's see if it works. Okay, so now this time when the thread enter this line of code, it makes sure that this one is not interrupted. It's not if it's not finished, it won't anything else will be stopped. So this is how it works in the background. I mean, it doesn't really, it's not really explained in the code, but this is how it works. So first, when the thread starts, it will execute this code. So it will execute the code inside the run method. And then it will enter this synchronized block. And this synchronized block protect the object of these classes. So if any other thread try to access this object, the object of these classes, this one, it will stop running. So here what it does, so we created the object and then we started the object. So when we start the object, we move on to this thread. It is synchronized. The object is protected from being interrupted. So it will run this line of code first. So it will run this line of code. And then, for example, if the execution goes back to the main thread, it will try to print this line, right? But on this line, it tries to access the object of that variable, which is protected by the synchronize keyword. So the execution of the main class will stop at this point, or yeah, it will stop at this point. And then it will let the loop to finish, and then the object or the lock of this object will be released, and then we can continue executing these two lines. So that's how it works with synchronized keyword. Let me charge my laptop first. Okay. Any questions so far?
Okay, sir. May I show my code because there is some problem. I have used synchronized keyword, but the problem is the result is always 0 and 190. Could I show my code?
Okay, go ahead.
I have a problem within it. I cannot start my. Oh, yes. Okay. Okay, sir. Is it really clear?
Yes.
Yes.
We can see that. Hang on, let me put it on the screen so the one here can see it. But I can't see it. It's too small. That's okay. It's okay.
Yes.
Okay, go ahead.
Yes. I have placed it synchronized and this like it like that has been shown in the screen. But when I try to run, the result is always 0 and 190 for all of the threads that I have been passed. For example, for the first thread that I call it as thread 1 and the second thread which I called as not thread 1. But I don't know which is my problem because I have placed it at the line 16, but
Okay.
I think there's.
I think I know what your problem is.
Yes.
It's because when you can you hear my voice, by the way.
Excuse me, sir.
Okay. So the problem is, if you look at your code, we can't really expect the execution of the thread, right? In my case, after I start the run process, after I start the thread, it runs the run method immediately. That's my guess. That's why once they lock the object, the line that prints the object doesn't work, or at least it is blocked. But in your case, it might be because before the thread has the chance to lock the object, it prints the result first. Does it make any sense?
Okay, yes.
Yeah, so there's another method to control the order of the execution of the thread, but we'll talk about it later. So this is a good example of why sometimes synchronized keyword doesn't really work.
Okay, sir. Okay,
Okay.
maybe that's all from me, sir. Yes,
Yeah.
maybe I will wait for the next.
Okay. Back sharing. My screen. Where's my Zoom? Um, Okay. Can you see the slides now? Anyone at home? Can you see the slides?
Yes, sir.
Yes, sir.
Okay, cool. Okay, another thing to control the thread executions is by setting the thread priority. So we can prioritize which thread should run more often. But it's not really the answer to our case before, but it's still nice to know. So basically, to set the priority of a thread, we can just call the set priority method from the object, from the thread object, and then we can just put one of these, or we can just put an integer. So it's between 1 to 10. 1 means the least prioritized, and 10 means the most, or the one with the higher priority, or the highest priority. But still, we can't really control the execution of the thread. So if we want to control, there are some stuff that we need to, or we can do basically. So before that, I need to mention there are several reasons why a thread poses executions. So there are 10 reasons, but we're not going to be discussing all of those. We're just going to be discussing 3 of those. So block on IO and block on synchronized object is pretty obvious. So it's like the same, it's like the previous example where the thread is blocked or stopped executing when it has to wait for an IO, or for example, if it has to wait for any data from the network, or if it has to wait for a synchronized object. And then we also have wait for an object and finish, preempt, suspended, or stop. But we're not going to be talking about, sorry, wrong screen. We're not going to be talking about this. We're going to be talking about these 3: yield, sleep, and join. So with yield, yield means like give up. So when you yield, you kind of gives up control. So when a thread yields, it gives up control to the other threads. So this is an example. So when the thread is running, and then it calls the thread.yield. So that means the current thread or the executing thread yields or gives up controls for other threads to run. So it's kind of commit a suicide. And then we'll have sleep. So with sleep, it's almost similar to yield. So it will pause the execution for several milliseconds. So it's pretty similar to yield. So it stops itself from executing. But the problem here with sleeping is that it it still holds onto all the locks it's grabbed. So it means if any thread locking a resource and then it goes to sleep, the lock is not released. So that means other threads trying to access the same resource won't be able to access or won't be able to continue running if it needs to access the resource. We'll try some of these later, and then the last one is to join. So join means it allows another thread to finish. So which one do you think is more suitable for our case? Yield, sleep, or join? So with join, if a thread joins another thread, so that means the joining thread or the one who calls the join will wait for the other thread to finish. So which one? Yield, sleep, or join? Okay, let's do some polling. So 1 for yield, 2 for sleep, 3 for join. Which one do you think is the most suitable for our problem earlier? So how do we make sure that the result is consistent? You can put it down on the class point. Okay, let's see. So most of you agree that join is the correct solutions. Okay. Now let's try then. Maybe Vishnu or the others, if you can, you can try and see if you get a consistent result uh, across the students. So first, let's try yielding. So I'm gonna yield my execution here. Yield is thread dot yield. Okay. I'm gonna yield. This is the main thread. I'm gonna yield. I'm gonna give up controls from the main threads. So I'm gonna run the project. I get 45 and 190. Okay, let's pause for a moment. Okay, let's continue. Okay, Vishnu, did you get the same result?
No, sir. It is still 0 and 100. 0 and 190.
Okay, so you still get the same result.
Yes.
Okay, so that means yield may not work for our case. Let's try sleeping. Let's sleep for 5 seconds. Is that how many zeros? Okay, 5 seconds. Okay, I'm gonna need to add some try catch. Okay, it's gonna execute a bit longer. Okay, Vishnu, did
Uh,
you get the same result?
yes, it is. The result is 45 and 190, but I think it is not the best solution.
Okay, so you get the you get a different result.
Yes.
Okay, so sleep works, but we have to wait for 5,000 milliseconds. Now let's try the other method. So instead of sleep, let's try joining. So I'm gonna join my thread one dot join. So that means my main thread will wait for thread one to finish. And then I will also wait for thread two to finish. Okay. What about the others? Maybe any of you tried? Same result? Okay. Vishnu, you get 45 and 190?
Yes, sir. It's the same answer. Yes.
Okay.
45 and 190.
Okay, so with join, we also get a consistent result. So it really depends on the case. Sometimes it's better to use yield. Sometimes it's better to use sleep. Sometimes it's better to use join. It really depends. In this case, because we definitely need to wait for the other threads to finish, we can safely call join. But sometimes it's better to use sleep, or sometimes it's better to just use yield. So the downside of using yield is after you give sub control, the processor uh, doesn't tell you which thread it will execute next. So it's just telling you, okay, the main thread gives up control, but we don't know either thread one or thread two will execute later. So that's the downside of using yield. So usually you use yield when you want a thread to stop executing for a while, but you don't really care which thread will be executed by the processor. So that's the difference between yield, sleep, and join. Any questions? No? Well, let's go back to the slide. Now, let's see what we can do with our web server. Well, I'm not going to put it in the slide. I'm just going to show it to you on NetBeans. So we have our previous web server. I'm just going to modify it a bit so that it can handle multiple clients at a time. This one. So this was from our previous meeting. So we have this loop where the server accepting the client, and then it will wait for the client to send some message, and then it will reply to the client, and then it will close the connection. Okay, so now before we get on, before we implement our multi-threaded web server, which line from this code should be moved to the run method? Starting from which line should we move these to the run method?
I think from socket client. From line 37.
From which line? Line number?
37.
37. So from this one.
Yes.
Wait. Okay. Yeah, so if you move this one to the new thread, so that means, well, it's kind of right and wrong. Sorry, just pause for a second, 2 seconds. Okay. Okay, so you can start from line 37, but usually what I do, I kind of start from line 42, or this one is, sorry, that's 41. So I usually start from line 41. So I want my server to accept the client first, and then I will pass the socket into the thread, and then the thread can create its own buffered reader and writer, and then use those buffered reader and writer to read and write message to the network. So if I want to implement a new multi-threaded server, I'm just gonna create a new class first, new Java class, and then let's call this client thread. And then, as usual, I'm just gonna extend this. Thread, and then create the constructor. And then override the run method. Okay. So I need to move which one? Okay, so I need to move these lines, maybe starting from this, gonna move it to the west thread class. Okay. I'm gonna move this to the run method. Okay, include them. Okay, lots of red lines, that's okay. Okay, in here we don't have the socket. We only have the socket in the main class, so we need some way to pass that information from the main class to this object. The way we do that, again, we can use the constructor. Then I'm gonna create a new object, sorry, a new attribute here, call it private socket client. It's gonna assign the variable this, and then for the sake of code cleanliness, just gonna type this client. So we know that it's an attribute, it's a class attribute. Okay, blah, blah, blah. Unreported IO exception. Okay, I'll enter the run block. This the client. Okay, we're missing the website root. Let's define the website root because it's supposed to be the same across. Because in this case, we're using the website, the same website. Let's just create a variable private string. What was it called? Website root. Website root, and then gonna use this as a parameter again. String and then this dot okay, we've got this. Okay, this website root plus URN. Well, so far so good. Okay, and then next, what we need to do here is just to create a new object, a new thread object. So it's just client thread, new client thread, like this. Then we just need to start it. Okay, we started the client thread, and let's just run it. Okay, now I'm gonna try with my browser. What's the port number? 80. Okay, so this is localhost slash index. Okay, so now I have two tabs. I don't know if there's any way to reload these tabs at the same time because it's not that long. And what we see here is actually not that much different from what we have. But if you have bigger file to transmit, let's download a bigger file. Let's try to download this one. Okay, I have a file called sample.pptx. So I'm just gonna put this here. It's really hard to see. Hang on. Wait. I don't think you're at home can see this. Okay, can you see the web browser?
Yes, sir.
Okay, wait a moment. Okay. Let's see. Hang on. Let's download it again and then move to the other tab. Okay, both I think have finished. It's not big enough. But anyway, if you have a big enough file, you can see that both tabs will still be downloading the same file. And the other tab doesn't have to wait for the first tab to finish. Because now we have the multi-threaded web server. Any questions, maybe? Oh, well.
Maybe I want to ask
Yeah, sure, go ahead.
why we accept the server outside of the thread when we could
Sorry, can you bit louder?
Okay. I want to ask about the line 37. Why don't we place it inside of the thread when I think when we use it in the thread, we could accept a lot of client. Yes, maybe something like that. Sir.
Why don't we accept the client inside the thread?
Yes, sir.
Okay. Well, I guess it's just a matter of preference because I accept it outside the thread so that I don't have to share my server socket object with the thread. So I just want to share the socket object with the thread. So the thread can do anything with the socket object, but it can't do anything with my server socket. So it's just to prevent the thread from accidentally killing the server socket. So that's why I did it. But you can still do it. You can share the server socket object inside the thread. Does that answer your question?
Yes, and then I know that the client is closing in the inside of the thread, but it is still in the loop side. Maksudnya masih di perulangan.
Okay, yeah, I get what you mean. So you mean when we close the thread, the object itself still exists in the loop, right?
Yes, sir.
Okay, so here's what happens with the loop actually. So when you accept a client, so you create another object in the memory, and then it does something with the job because we have our own thread. And then in the next iteration, we will create another client object, and then we will create the we will also create the client thread object for the new client, and that's how it goes. So basically, this is actually a bad practice because we don't remove the object from the memory. But fortunately, in Java, we have the garbage collector. So when the garbage collector knows that the object is no longer used, it will remove the object from the memory. So basically, the client thread object here from the current iteration is different from the client thread from the next iteration. So it's a different object sharing the same name and the same type. And basically, we don't really use it now because we don't really care about interacting with this client. We'll see in the next meeting how we deal with multiple clients, and we need to access them all. But for now, this is what we have. Does that answer the question?
Okay, sir. It's really answering my question.
Okay. Any other questions? If not, I'm gonna give you a good news because next week we won't have the midterm exam because we don't have midterm exam. But I have bad news. That is, we have another assignment for next week. But it's not a complicated one. We just have two requirements here. First is I need you to modify your web server to be able to handle multiple clients at the same time. So to test this, you can install what's called an extension on Google Chrome called what's called, I can't remember. Reload all, I think, something like that. I'll share more information in the classroom. But anyway, I need you to modify your web server to be able to handle multiple clients at the same time. That means you need to use the multi-threading approach. And then the second requirement is you need to make your web server to being able to handle parallel downloads from any download manager, like IDM or any download manager you have. So as a hint for this second requirement, you need the range header. So there's a header called range, and you also need the 206 response code. That's really for the next assignment. So that's the two requirements for the next assignment. Should be okay. And again, if you need to, or if you feel that your previous assignment is not good enough, you can you can fix it and then show it to me later. Okay, any questions? If not, that's the end of today. We'll see next week. No midterm exam. You'll save from the exam, not from the assignment. Okay. Well, thank you. I'll see you guys next week. Oh, next week will be online. So it will be an online meeting. It's faster if you do the demo like that. Okay, cool. Right, I'm gonna end the meeting. I'll see you guys again next week.
Thank you, sir.
Thank you very
Thank
much.
you, sir.